everyone, welcome back to the channel AI Verse. So yesterday we have covered this flow of model building. We have seen each and every step in detail. In each step, what things are going to be happen for the model training. All we have covered yesterday. So now it's time to go on the algorithms which are in the supervised machine learning, unsupervised, or reinforcement. And just take one by one. In the supervised machine learning first, there is one algorithm, linear regression. Okay, so what is the linear regression actually? The linear regression is a supervised machine learning algorithm used to predict the continuous values like salaries, price, marks, temperature based on one or more input features. Okay, uh, why they have mentioned one or more input features? Because there are two types of linear regression. What are that? One is a simple linear regression and another is multiple linear regression. There are two types. Okay, so in a simple linear regression, what formula is there? Y equal to mx plus c. So what is going to be happen over here? As I have mentioned over here also, y equal to mx plus c for the simple linear equation. Simple linear regression. Okay. So what is y over here? There is a dependent variable or predicted value. What is the x in this equation? Independent variable which is the input value. What is m? M is the slope of line and c is the intercept. So over here there is only one dependent value or only one independent value. Okay. But what things are going to be happen in the multiple linear regression? Y equal to mx1 plus mx2 plus mx3 plus and so on plus b or c. Okay, so over here there are multiple independent variable, that is x1, x2, x3, and only one dependent variable, that is y. Y is totally dependent on x1, x2, x3, x4, up to whatever it may be. So over here there are multiple independent variable and only one dependent variable, and that is called the multiple linear regression. Okay, so over here the multiple, whatever it may be, the multiple or simple linear regression. In the linear regression, it's mainly depend on the continuous value. It predicts only continuous values. You can see in this diagram, if there are the continuous value, then the graph will be look like this, and it tries to draw one best fitting line in between the data point, and that line should be like that the each data point is nearly to that line, so that the error of each point or distance between the line and the data point should be the less, so that the error should be less and accuracy should be high. Okay, so likewise the graph will be drawn based on the data points, and the base fitting line also uh, put over there. Likewise, error should be the minimum. Okay, what it tells, the find the base fitting line by minimizing the prediction error, least square method. What it tells, as I have already explained, it try to find the base fitting line in between the data points, so that error should be minimum or predicted errors should be the minimum. Sorry. What the tail, the second line, it calculates coefficient for the variables that minimize the error prediction. That's also the same meaning. It try to minimize the error by drawing the base fitting line. And once the base fitting line occurred or it found the pattern, so the model will learn automatically how the things are going to be happen when inputs are coming, and what output should I give. So model will get trained, and whenever we are giving a new input, then model gives the better output based on the pre-learning. Whatever it learns, based on that it will give us an output. Okay, as I have explained the y equal to mx plus c example, which is the base equation of baseline. Okay, done. So over here, just see this graph. What is happen over here? Okay, over here this is a linear, this is the non-linear, and this one is also non-linear. Okay, why this is non-linear? Sorry, why this is linear? Because there is a straight line. We can draw the straight line over here. Sorry, we can draw a straight line over here in between the data points. So that is called the linear regression. Why this is non-linear? So over here the data points are spreading like that, like a way. We cannot draw the straight line in any of the cost. Okay, we cannot draw the straight line. How we can draw the straight line? Not at all. Okay, because there are some data points, there are some data points which are totally away from the this straight line. And the cause for that, the accuracy will be less and errors are high. Okay, that is called, so that it's called a non-linear regression. We cannot draw the base fitting line over there, and in this graph also we cannot draw the straight line. So there are multiple data points which are going away from the straight line, and that's the reason for less accuracy. So that what linear regression, in simple words, in linear regression, all the data points are spreading whatever in the pattern. Still, in linear regression, the base fitting line is most important, because when the line is drawn, then that line should be in a way that each data point having the minimum distance from that line, so that model will train perfectly with the less accuracy and less errors and the highest accuracy. So main motive is this only. So just taken in one simple example. Okay, just taken a simple example. Okay, just one simple example. I'm drawing just table. The example is totally related on the continuous data. because uh, the linear regression is totally depend on the continuous data only. And we are taking the example of the simple linear regression. Okay, this x is our studies. Okay, is a y column is for marks. Well, so the data points over here are 1, 2, 3, 4, and its target 2, its target 4, 3 is target 6, and 4 is target 8. Well, as this is the most simplest example for the linear regression, then you can see that there is only one variable x, which is the independent variable, and y is the independent variable. That is only one variable. So what's the formula for the simple linear regression? Y equal to mx plus c. Okay, so this is the y, which is the outcome or predicted value. This is the x, which is the input value, as we have seen previously over here. Okay, so how the graph is coming from these data points? So graph is look like in a way that this is a x variable, this is the x axis, sorry, and this is the y axis. So over here, what are the some points? This is the 0, this is 1, this is 2, this is 3, and 4. Well, just I'm arranging it in a single line. Okay, so same thing over here also. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, just arranging it in a well manner. Okay, 6, 5, 4. Okay, this is the random graph. Okay, we have to not give any exam over here. Just for the simple explanation, I'm giving this example. Okay, so over here, for the one which is x, that is the input value. What is the target? 2 over here. So what's that? Okay, so how the line is going to be come over here? For the 1 is a 2, so that will come over here. Okay, for the 2 there is a 4, that will come over here. For the 3 there is 6, this will come over here something. 4 there is 8, that will come over here. So is there any possibility to draw a perfect line? Is there any possibility? Yes, this is the possibility to draw the simple fittest line by maximizing the errors from the line with the data points. So this is the best fitting line. So in future, if I'll give an input as a phi, so what it will predict, so phi comes over here something, okay, and by learning this pattern the outcome will be 10. So line comes over here something, that is the value of 10, and it will give us an output of 10. So I think I can able to give you an better knowledge regarding the simple linear regression. Likewise, same things are happening with the multiple linear regression also. Only the thing is that there are the multiple independent points and there is only one dependent point. Okay, well, that is the output is totally depend on the multiple features. There is only one target column and there are multiple inputs inputs column. So likewise, the things are going to be happen, and in the background, the calculation. What calculations are to be done in the background? How the slopes, what's the m, y equal to mx plus c, you have seen this formula, okay? What is m, how m is going to be calculated in between this line, okay? How? So there is a formula for m, that is y2 minus y1 divided by x2 minus x1. This is the formula for slope. This formula for slope, finding the slope. Or just take an example, that is 1 2, okay? First row there is 1 comma, its target is 2, and just take second, there is this one 2 4, 1 2 and 2 4, 2 1 4. So how the slope is going to be calculated in between this? So this is the x1, this is, sorry, so this one is a x1, 1 minute, x1, 2 is a x2, this is y1, and this is 4 is y2, okay? So how the slope is going to be calculated? What's the formula? M equal to y2 minus y1. That means 4 minus 2. 4 minus 2. And x2 minus x1. That is 2 minus 1. 2 minus 1. So what's the outcome of it? What's the outcome? Equal to 5 divided by 1. So its slope is the 5. Okay. So likewise, in the background, the calculations are going to be happen in this way, and the slope, it helps to draw the best fitting line in between the data points. So likewise, we can predict the future outcomes based on the given data set. So this is the simplest data set I have given to you, and based on this I have drawn the base fitting line in between the data points. In like with that, the distance of each data points is minimum from the base fitting line. So likewise, I have explained the background calculations also, given the simple example, drawing the graph of it. Okay, explain these two types also, simple linear regression, multiple linear regression. Its formula also, y equal to mx plus c. What are the meaning of each term in the formula. It's a graphs, some linear, non-linear regression. Other things are going to be happen in linear regression. I explain. So how we can implement it for the real world use case. So that things we will cover in the next video. That's the coding part, and that totally based on the previous lecture what we were seeing, the how the model is going to be predicted, all the steps we should follow for that coding part, and that we'll see in the next video. I think you all have got an idea for today's agenda. Okay, in the next video we will cover the next algorithm, that is the logistic regression. Okay, just giving the simple overview of logistic regression. It's mainly depend on the categorical, as previous algorithm, that is linear regression, is totally depend on the numerical variables, and this is one is depend on the categorical, and it's used for the classification purpose. Okay, and its formula is 1 upon 1 plus e raised to minus z. So these things we will cover in details in the next video. Just revise one first algorithm. If you have any doubt related to these algorithms, just drop comment in the comment box. I'll try to solve your all the questions. Okay, so thank you so much guys for watching this video. We will meet in the next video. So thank you so much. Thank you. Bye bye.